Moving right along to section 3, topic 9, angle preserving transformations. So we've got the figures below. Lines L1 and L2 are parallel, and figure B is a rotation of figure A. All right. The figures above represent an angle preserving transformation. So what does angle preserving transformation mean? Well, we're preserving the angles. So all angles keep the same measurement. So, for instance, if this were, I don't know, let's try to guess at what that would be, 75 degrees, then this one over here is, after the whole parallel lines have been rotated, it's still the same 70, what did I say, 75 degrees? So that's what that means. You can rotate it around, but the angles are going to stay the same measurement. Does the transformation preserve parallelism? Okay, so are our lines still parallel? Yes. Okay, a rotation preserves distance, size, direction, okay, and you can kind of look at the tick marks that are there. Okay, that's telling us that it's still parallel. Okay, so I'm going to put and look at the tick marks. Okay, so we're going to look at the angle preserving transformations and how they refer to reflections, translations, rotations, and dilations. So the angle preserving transformations refer to reflection, translation, rotation, and dilation that preserve angle measure and parallelism. That's kind of hard. There we go. All right. The conditions for parallelism of two lines cut by a transversal are we have corresponding angles, alternate interior angles, alternate exterior angles. I hope you remember those from previous lessons. They are all congruent. Same side consecutive angles are supplementary. Okay, so those vocab terms aren't going to go away. So let's practice what we're doing with all of this. So I've got the figure below, which will have L1 parallel to L2. Determine the angles that are congruent with angle A. So I'm looking at angle A. Which other angles are congruent with angle A after a translation of A? Okay, so if what would be congruent with A? Well, I've got angle, let's see, a translation. I've got angle D. I've got angle E. And I've got angle H. Okay. Determine the angles that are supplementary with angle A and angle E after a 180-degree rotation of A. Okay, so if I'm looking at supplementary, then I know that these are supplementary these are supplementary, and with E, these are supplementary, these are supplementary. So angle B, angle C, angle F, angle G. Oh, this is a little bit difficult over here, so I'm going to try to zoom it in as much as I can. It says we are going to reflect the image above across y equals x. So I'm going to go ahead and draw my line of y equals x. And if you can do that, in the meantime, see if you can look up the rule from a couple lessons ago. Does that look good? Yay. Or if you remember the rule from a couple lessons ago. If you don't, I'll help you out. X comma y is going to transform, I didn't leave myself enough room, to y comma x. Okay, so let's see. A is currently at, let's see, 2, 4, 6. I don't know if you guys have the same problem I do, but it's very hard to see. That's 2, 4, 6, negative 8, negative 10. Sorry, the bell's ringing. So A is at negative 10, comma 5. So we're going to flip-flop that. So A would be at 5, comma negative 10. Okay. B is at negative 2, comma 4. So B prime would be at 4, comma negative 2. All right, I'm going to draw my segment between the two. Okay, and let's see. Oh, I didn't have O in there. O is at negative 5. Yep, negative 5, and a little bit higher than 4. So a little bit more than 4 to negative 5. Actually, it's going to be right on that line because I said a little bit more than that. About right there. I said this was hard for a reason. Okay, let's see. I've got P is at negative 10, comma 8. So we're going to look at 8, comma negative 10. And R is at negative 2, comma 7. So we're going to look at 7, comma negative 2. Okay, so it's starting to look good. Okay, N is at negative 8. 8. And is at negative 8, comma, looks to be almost 8, so almost 8 to negative 8 right here. N prime. Okay, and oh, M. All right, and M is at negative 9, comma 9, so we'll go to 9, comma negative 9, and extend that line out. Okay, whew, that was difficult trying to figure all those little points that weren't quite points out. It says if angle MOB is equal to 117 degrees. Okay, so MOB right here. Okay, and angle M prime, N prime, P prime is at 63 degrees. M prime, I didn't write M prime, did I? N prime, P prime is 63 degrees. Prove that after a reflection, angle M prime, O prime, B prime is equal to 117. Well, it's easy. We know that reflections preserve parallelism. And angle measure. And. Okay, so it doesn't matter how you rotate it, flip it, or even dilate it, and you're going to get to that coming up in a couple weeks. It is going to preserve the angle measurements as well as your parallelism. So let's take a look and see what we can do. We're actually going to write like a paragraph proof with it. So yay, we get to do more proofs. So let's go ahead and look at the next page. The figure in quadrant 3 of the coordinate plane below is a transformation of the figure in quadrant 2. Okay, so first of all, this is my pre-image, and the one in quadrant 3 is my image, or the result. So what type of transformation is shown above, and then justify your answer. So what has happened above? It's not a translation, not a rotation, so it'd have to be a reflection. And what did we reflect over? The x-axis. So what's that rule? X comma y. The x comma negative y. All right, so you can look at one of your coordinates if you want to and make sure that that rule applies. Okay, write a paragraph proof to prove that angle 6 and angle F are supplementary. So angle 6 and angle F are supplementary. And you can look at them, even though they look like they're in the same position, because a reflection happened, they're not. So angle F actually corresponds to angle 7. So this is the thought process. What we need to do is we need to kind of, from 6 to F, we need to kind of include 7 in there. So if I look at 7, starting with our pre-image, 6 and 7, they are supplementary angles, okay? Because they're same side interior, same side consecutive interior. And then 7 and F are congruent because of the angle measure is preserved in a reflection. So that's what we're going to say. We're going to talk about 6 and 7 being supplementary angles because they're same side consecutive. Then we're going to talk about 7 and F being congruent because the angle measure is preserved in a reflection. Got it. All right. So let's basically start writing it. Angles. Ooh, that's not going to help. Angle 6 and angle 7 are supplementary. And if you just write sup, I'll know what you mean, as long as you know what you mean. They are supplementary as well as F and G. Because of same side, consecutive, angles theorem. Angle 6 is congruent to angle G. Angle 7 is congruent to angle S. Where did I get angle S from? F. I don't know. My notes, I had S down there. Don't know why that. And that is because angle measures angle measure is preserved in a reflection. Therefore, angle 6 and angle F are supplementary by substitution. I can just substitute in those values. That's it. Okay, so again, I know I'm throwing a lot at you and it's not easy doing it like this, but go back and read through that again, see if that's logical. You're making a connection between the pre-image and the image and then going from there. We're going to do the same thing on number 4. So giving you a chance to finish writing that. Star it so you can go back and just read it through. For the EOC, you're not going to have to write a paragraph like that, but you might have to input some, like a drop-down menu and input some steps in there. For 4, we have another figure. Do we have a reflection, a translation, or a rotation? If you said translation, yay! All right, so we do have a translation. Okay, and we know what has happened. Let's see, we can take, I don't know, this point right here to this point over here. And it looks like I've gone to the right 14. And it looks like I've gone to the left, or I'm sorry, down 12. So we're going to write a paragraph proof to prove that 4 and E are congruent. So there's 4 and E. So we got to make a connection between 4 and D. And then we need to make a connection between D and E. Because, yeah, if I make a connection between 4 and D, and I look at D right here, I can see that D and E are alternate exterior angles. Okay, so this one's going to be a little bit easier than the last one, because I only have to show the connection between 4 and D and E. So if you're already thinking transitive property, you're doing great. Okay. So 4 and D. So again, we have measures preserved in translation. So angle 4 is congruent to angle D, since angle measures or angle measure is preserved in a translation. Okay, now I'm looking at, so I made the connection between 4 and D. Now I'm going to make the connection between D and E. So angle D is congruent to angle E because of alternate exterior angles theorem. No, I'm not. Yeah. Thus, angle 4 is congruent to angle E by the transitive property. That was just Miss Bird coming in. She says hi.
Hi, everybody.
Do you hear?
I'm so sorry.
It's okay. All right. And we have one last page. I'll give you a chance to finish writing that. Okay, did you catch up? All right, so let's go ahead and take a look at number 5. Ooh, and we get to do some math over here. Okay, so some actual solving for equations. All right, so we're looking at our pre-image and our image, and it wants us to find the following values and explain how you found the answers. Okay, so if I'm looking at all these angles, so let me just highlight them. I've got angle 2, angle 4, angle G, and angle H. Okay, so 2, 4, and G, I hope that you can see that all of those are congruent. They're going to be the same measure. But angle H is going to be supplementary to all of those. So let's just write that down. Okay, so now what we're going to do is we're going to find x. So the first way that I'm going to do that is if I'm looking at trying to find x, I see that angle 2 has x in it, and so does angle G, and they are both congruent, and congruent angles have equal measure. So let's go ahead and find x by putting the measure of angle 2 equal to the measure of angle G. So let's go ahead and write those expressions and put them together with an equal sign. All right, and I know you guys are multi-step equation wizards, so we're going to subtract the 3x on each side. We'll end up with x, add the 11 on each side. We're going to end up with 14. Awesome. Okay, to find y, let's do the same thing. So with y, I have the measure of angle 4. The only other thing with y in it is the measure of angle h. Now, those are not equal to each other. Those are supplementary. So we have to put those two expressions, add them together, and set them equal to 180. So measure of angle 4 plus the measure of angle h is equal to 180. So 4y plus 1 plus 13y minus 8 is equal to 180. So I'm going to combine my like terms. Gives me 17y minus 7 equals 180. Add 7 on each side, so I've got 17y equals 187. Divide each side by 17, and you get y is equal to 11. All right, so now we've got to use that information to find measure of angle 1. All right, so the measure of angle 1, there's angle 1. It is actually congruent to the measure of angle h. Okay, so 1 and h are actually the same thing as 8, alternate exterior angles. So let's set those equal to each other. I know that it's going to be equal to the measure of angle h, so I can just plug in y. So 13 times y, which is 11, minus 8, is going to give us 135 degrees. And then the last one on here, measure of angle D. Where is angle D? Right here. Okay, it's going to be congruent to the measure of angle G. And let's see, angle G is 3x, which in this case we already know x is 14, plus 3. Calculate that out, and we're going to get 45 degrees. Almost done. Okay, so we're going to beat the test. the figure in the second quadrant of the coordinate plane below was transformed into the figure in the first quadrant. Mark the most appropriate answer in each shape below. Okay, so let's see. This is our pre-image to our image. All right, so the figure was, how did we get over there? Was it dilated, rotated, reflected, translated? Well, we haven't done anything with dilations yet, so you can go ahead and get rid of that. And you can tell that the orientation of the points are opposite, so that does show that we have a reflection. And what was it reflected over? Was it reflected over the x-axis? No, that's down here. Was it reflected over the y-axis? Looks like it. Okay, so part B says angle 1 is related to angle C. How? Okay, so if I reflect over angle 1 and angle E are corresponding to each other, and angle E and angle C, let's see, angle E and angle B are vertical angles, so B and C are actually supplementary. And we have a part C to this, okay? So part C, if you flip over, I'm going to keep this page up, so you guys flip over. It says angle 6 and angle G. What's the relationship between angle 6 and angle G? So angle 6 and angle G. Okay, so 6 corresponds with, trying to see which one it would correspond with over there. Oh, with B. And B and G are alternate interior angles, so they are congruent to each other. We've got this very last one. I know this is a long video, so I'm trying to hurry up. So consider the same figure as the previous question. If angle, or the measure of angle 7 is 2x minus 4, and angle B is 6x, then angle 8, and we need to find the measure of angle 8, and we need to find the measure of angle H. So as I'm looking at these, so the measure of angle 7 and the measure of angle B. So let's look at angle 7 and angle B. They are actually going to be congruent or supplementary. Well, 7, if I were to look at my reflection, is going to map onto C. And angle B and angle C are same side interior, so they are supplementary. So they will add to 180 degrees. That's going to give you 8x minus 4 equals 180 degrees. I'm going to add 4 to each side and divide by 8. I'm assuming you have your calculator. So x is equal to 23. Okay, and let's see, angle 8. Oh, okay. So to find out what angle 8 is, I'm going to plug in measure 7. Let's see. So measure of angle 7 is 2x minus 4. And we know now that x is 23 minus 4 gives us 42 degrees. Okay, and if I took 180 minus 42, and why did I do that? Because 7 and 8 are supplementary. Okay, so 108 minus 42 is going to give us 138 degrees. Okay, again, I found the measure of 7, and I know 7 and 8 make a linear pair. They're supplementary. So I just did 180 minus 42 to do that. Angle B, where was I getting angle B from? I'm sorry, angle H. Oh, is congruent to angle 8. Is congruent to 4, and angle 4 is going to be 42 degrees. And again, how did I know that angle 4 is 42 degrees? Because angle 7 was 42 degrees, and 7 and 4 are a vertical pair. And 4 and H, okay, it's our pre-image and image. All right, I know that was a long lesson, a little bit confusing. Take your time on the prep